Hi everyone. Now I received quite a few requests from you all that you are not able to see why sometimes temperature expressed in Kelvin has to be represented in Kelvin. Sometimes in degrees Celsius has to be represented in degrees Celsius, and why sometimes it does not matter whether it's in Kelvin or degrees Celsius. I understand your concern, so this video was specially crafted to show you visually uh, how you could have misunderstood and how to rectify the errors. Now, you recall that the temperature in Kelvin is actually equals to temperature in degrees Celsius plus 273. So why there's the confusion among students is because there are two scenarios here. One is when we ask for the temperature of a substance, and the other when we ask for the change in temperature. Now, when we ask for temperature of a substance, and we give you a problem like temperature of a substance is 400 Kelvin, calculate its temperature in degrees Celsius. And we know that temperature in Kelvin equals temperature in degrees Celsius plus 273. So that will give you 400 plus temperature in degrees Celsius plus 273, and temperature in degrees Celsius equals 400 minus 273, which is 127 degrees Celsius. I think this, most of you have no concern grasping it. So over here, you can tell that the temperature is 400 Kelvin in Kelvin, and the temperature in degrees Celsius will be 127. I think the confusion comes on the next part, which is when we ask for a change in temperature. A simple problem here, the temperature of a substance is initially 120 degrees Celsius. Its temperature rises to 150 degrees Celsius. So calculate the temperature change in degrees Celsius and in Kelvin. So let's talk about degrees Celsius first. So I have theta 1 equals 120 degrees Celsius, theta 2 equals 150 degrees Celsius. Now the change in temperature will be theta 2 minus theta 1, which is 30 degrees Celsius. Straightforward, right? Because the initial readings are all given in degrees Celsius. How about the temperature change in Kelvin? Now let theta 3, sorry, there's an error here. Now let theta 3 be equal to 120 degrees Celsius plus 273, which will give us 393 Kelvin. Theta 4 will be equals to 150 degrees Celsius plus 273, which is now 423 Kelvin. So in the next part of the question, what I did was I converted all the temperature to Kelvin first. And then when I calculate the change, which is theta 4 minus theta 3, I get back the same value, 30 Kelvin. And therefore, a change in degrees Celsius is equal to a change in Kelvin. And to further illustrate my point, let's prove it in a very algebraic form. Let theta 1 be the initial temperature in degrees Celsius and theta 2 be the final temperature in degrees Celsius. So the change in Kelvin will be equals to theta 2 plus 273 minus, open bracket, theta 1 plus 273, close bracket. And when we remove the bracket, this is what it looks like. So it becomes minus theta 1 minus 273. And this plus 273 minus 273 kind of cancel itself out. And the change has become theta 2 minus theta 1. So therefore, change in degree Celsius equals change in Kelvin.